So this is a quick example that shows one of the more interesting uses of superposition, especially for a linear circuit. So you'll notice in this circuit we have just constant voltage and current supplies, or DC, and then we have just resistors. So this is a linear circuit. So with superposition, we don't necessarily have to know everything, all the components defined. If we can just be given two scenarios and the outcome, then we can use that. So let's look at how that works. So for the first scenario, we see that when V is equal to 5 and I is equal to 2 amps, so in other words, this would be 5 volts, this would be 2 amps. They tell us that IX then is equal to 1. So in that case, we can express that then as 5. These are constants, have constant linear relationships. So we'll have 5 times what we'll call CV, that's our voltage, plus 2 plus 2 times CI, it's our constant current, that the outcome of the component we're looking for here is equal to 1. So that one was equal to 1. So then we can come back and say, okay, we're given us another set of conditions. Now we're told that when this is 5 and this is minus 2, so that means the current actually be flowing that way, that this value then would then be 0. No current flows there. So then we can write that as, again, 5 times CV, but this time it's minus 2 times our CI, our current constant, and that's going to equal to 0. So now we have two equations, two unknowns, and we should be able to solve this pretty easily. So to do that, we can just solve it real quick. If we add these two together, then we get 10 CV. This will be 0, and then this is equal to 1. So that being the case, then we have CV is equal to 0.1. And then if we substitute that back into either of these equations, we should be able to solve for that CI is equal to 0.25. So these are our constants. Let me write this consistently. So this will be 0.1 and 0.25. So now they're giving us a third situation, and they want us to use this information to come up with the new calculation. So in this case, they're telling us that now V is equal to 6 and our I is equal to 3, and they want to know, in that case, what would IX be? So here we can just apply these constant linear coefficients. So now we'll have 6 times 0.1 plus 3 times 0.25. And so when we calculate that out, that comes to 1.35 amps. So under those conditions, that's what this current would be. And so it's one of the more interesting applications or characteristics of superposition. That's how we can use it. We don't have to necessarily know everything in the circuit. If we can just get, if it's a linear circuit, if we can get two scenarios and the results, then we can use the linearity property and determine what the output will be for any input using these constants.